Hey everybody, how's it going? Mr. Cornell here, ready to go over some angles of rotation with you in trigonometry. Okay, so here's our basic axes here with our first, second, third, and fourth quadrant. Okay, and what we're used to doing, if you already went through geometry, is when we're measuring angles, we're measuring in this direction here, in our counterclockwise direction, starting from our first quadrant here. Okay, so when we're moving in a positive rotation, okay, measuring an angle, you're moving in the counterclockwise direction. And then it could be said that when you're going this way, or in the clockwise direction, that's going to be measuring in the negative direction. So, okay, straight line here, so if I was measuring this distance here, okay, it would be 180 degrees. But if I started going in the opposite direction, I'm going to call it negative 180 degrees. Okay, so that's the difference between going in a positive and negative rotation. Okay, then we're going to have coterminal angles. Okay, so coterminal angles is angles who share the same initial and terminal side. So if you look at what I have measured already did here, so your initial side is here, okay, that's where you're starting from, and that's on our x-axis. And then your terminal ray is where you're ending, okay, to terminate, terminal. So here it is here, that's a terminal ray. So take this example that I just did before. So the terminal ray would have been right here, and we measured 180 degrees. Its coterminal goes in the other direction, okay, so it's going in, for this case, would be in the negative direction, and it would be negative 180 degrees. So by definition, a coterminal, okay, would be an angle whose measure shares the same initial and terminal side. Okay, and in the example I just did, so you could say here was your initial, and then here was my terminal side. Okay, so here is my first angle. So his coterminal angle would be going in that way, okay, and it would be negative 180 degrees. And it could either be positive or negative, okay? But in all cases of these angles, they are always going to add up to 360 degrees, okay? So we'll just write that down. An angle who shares the same initial and terminal side. Okay? And remember, they move in opposite directions. So here are some quick examples here. So if I had an angle that was 30 degrees, so let me just draw that for you so you can see it quick, okay? So here would be 30 degrees. So by definition, the coterminal will share this terminal side, right? But it's going to move in the opposite direction. So it's going to move in this direction here. So since it moved in that direction there, it's moving in the negative direction. Remember, they all have to add up to 360 degrees. So if I subtract 30 minus 360, that's going to be negative 330 degrees. And that's where they got that negative 330 from. Okay? Or I can give you the negative 100. Okay? Now I'm giving you negative 100. So they started by moving in the negative direction. Okay, so remember, okay, each quadrant is 90 degrees. So negative 100 would be right around here, right? So here's your negative 100. So now the other direction is going to be positive. And how many degrees are left? So here you're going to be doing negative 100 plus 360 degrees. And that's where they get the 360. And then here you're going to do 225 minus 360, and that's going to give you negative 135. So if you want to have a formula for this or something, so when you have a positive, okay, your first angle is positive, you're going to subtract 360, If your first angle is negative, you're going to add 360, okay? But just know that those two angles are going to give you a sum of 360 degrees, okay? Now we have a reference angle. I think it would be easier for me to show you what a reference angle is before we actually just sat and wrote it down, because the definition is really weird and confusing. So let's say I drew an angle, and here's the angle right there. A reference angle, okay, would be an angle measured closest to the x-axis. So if this was my angle, this would be considered the reference angle. If I had this angle, right, I don't know, let's pretend that it's, I don't know, 150 degrees, right? By definition, a reference angle, and not coterminal, nothing to do with that, is the angle whose measure is from the terminal ray to its closest x-axis. So here's the terminal, and then here, right there, that is what's closest to the x-axis. So again, straight lines are 180. So that means that there's 30 degrees left. Okay, so this would be considered the reference angle there. What happens if I'm down here in the third quadrant? Let's say that he is, I don't know, 200 degrees, right? The reference angle is that terminal ray and then the closest x-axis. Well, here's the x-axis, so then right here, this distance here would be considered the reference angle. So how many degrees? Remember, this is 180. How many more degrees did I go to 200? And that would be 20 degrees more. Okay, so there you go there. There's 20 degrees for that reference angle there. And then the final one, okay, when you're in the fourth quadrant, okay, let's say it's 300 degrees, okay, that angle. Closest for the reference angle, again, to the x-axis would be that distance here. That's considered the reference angle. So a little bit different, remember? Okay, so I already had 300. Now I have to complete this because I got to get to this x-axis here. How many degrees are left? And that's 60, because together, okay, it's going to make a full circle, and a full circle is 360. Okay, and then let's say that this angle was 30, the reference angle is still 30. Okay, that one doesn't really change too much. All right, so just kind of keep that in mind. This is where your reference angle would be in each one of the quadrants. So there's your third quadrant, that's where it would be. There's your third, and then here's your fourth quadrant, and the first. All right, so if we want to put that into words, if you really want to know, okay, is the angle that the given angle makes with the closest x-axis. I think that's the easiest way to write it, okay? The angle that the given angle makes, okay, with the closest x-axis, okay? So the angle is the angle that you started with, okay? The given angle, so this is talking about the reference angle, that the given angle, so that's the angle they gave you, okay? So there it is in words. All right, so let's do some practice with all this. Okay. So again, real quick, just so that you remember, this is 0 degrees, this is 90, this is 180, this is 270, and then your final completes your 360. So when they start giving you angle measures, you'll be able to kind of sketch where those numbers lie. So starting with theta, 145, that's going to be right around here. So right there, that's 145. So they want, okay, where are we? We're going to be in the second quadrant. So my first angle was 145. So now I'm going to subtract that from 360, and I'm going to get negative 215 degrees. Okay, and that's going in the opposite direction to complete the circle, negative 215. Then we go to that reference angle again, okay, and that's the terminal to the x-axis. Okay, terminal to the x-axis. So I know that that's 180. So if I did 180 minus 45, that's going to be 35 degrees. Okay, and then there's your reference angle. Okay, next one is positive 320. So I know a 90, 80, 270. So then there's going to be my 320 degrees. I am sitting here in the fourth quadrant. This is 320. Subtract that from 360. I have negative 60 degrees left, and that's going to be negative because you're measuring in this direction here. That's negative 60. Then nice and simple one, reference angle is also going to be in that same location, but he's not negative anymore. He's always going to be a positive. All right, so if you want to give a little pause right now and try to do C, D for your own practice, awesome. Otherwise, I'm going to keep going. Here's 72. I'm going to go before that 90. So there you go, 72. Subtract that from 360. We're going to get negative 288. So then your reference angle, we're in the first quadrant, so it's going to be the same angle. Okay, here's a negative. Okay, so we're going to move negative 90, negative 180. Okay, and then boom, you're going to be right over here. Okay, so I went in the negative direction. So that's negative 210. I'm sitting over there in the second quadrant. So my first angle was negative 210. So now think about it, or be careful, because now your coterminal angle is going to be moving in the positive direction. So again, to complete 360, we'll add 360 and we'll get 150. Okay, so that's 150 degrees. Now let's figure out our reference angle. Here's my x-axis, here's the terminal, so right there. There's your reference angle. That's 180, okay, because you're in a straight line right there, so 180 minus 50 is 30, so your reference angle is 30 degrees. All right, let's keep going. What do we have next? All right, some more practice. Again, give a pause, try it yourself. Okay, if you want to try E and F, and then watch me do G, because G might start to confuse people a little bit. All right, so here we go at 250, 9, 18. That would hit 27, so 250 is going to be down here in the third quadrant. Okay, so there's your 250 there. Subtract that from 360 to get your negative direction coterminal. Okay, and that's going to be negative 110. Now let's grab our reference angle. Here's my x-axis. Here's my terminal ray. So then right there, that is going to be your reference angle there, and that's going to be 70 degrees. Okay, and again, okay, because this is a straight line at 180, so you can do 180 minus 250. That's going to give you the 70, or other way around for positive. All right, so now here we go. We're going in the negative direction. Okay, so that's negative 9, 18, 27. Right there is going to be your 310. Okay, so now we are in the first quadrant. Okay, how many more degrees do you need to get to 50? Okay, and that's going to be moving in the opposite direction, so it's going to be positive. So there you go, 50. And that's going to tell you your reference angle also. Okay, 50. All right, 360, 460. Positive. Okay, 9, 18, 27. All right, I just completed a full circle. That was 360. So I got to keep going for another 100 degrees. Okay, so that's 360 and 100. That's how you get your 460. So then you got to figure out what's left. But it's going to be a little different because you went around and around. So once you get around, you start back at 0 again. So instead of calling this 460, I'm going to call it 100. Okay, so where am I? I'm in the second quadrant, and my angle is 100 degrees. Okay, because we went around. So once you go around, you're starting back at 0 again. So how many more degrees did I have to go? I had to go 100 more degrees. All right, so that's how I'm going to get my first angle at 100. Now I'm going to move in the opposite direction to create this coterminal. and that's going to be negative 260. Now I got to grab my reference angle. That's going to be from here to here, which is going to be 80 degrees. Okay, again, you got your 180. All right, let's try that. You want to give a pause, try it yourself. Now go in the opposite direction for negative 400. Okay, so there you go at negative 360. So then if you already did 360, how much is left over? Okay, then there's 40 degrees left over. So you're drawing right there, negative 40 degrees. Okay, because you went around for 360, and then you have 60 degrees left. We're in the fourth quadrant. Okay, if we're going to find our coterminal, go in the opposite direction. Okay, so if you have negative 40, go around this way. How much is left? That's 320. Remember, you can add 360 there. There's your reference angle. Here's your x-axis, and there's your terminal ray, and it's going to be positive. All right, so there's some work there with that. So now the next two exercises here are kind of word problems. They're multiple choice. If you want to give a pause, try them, and then I'll go over them. That would be great too. We're going to be going around and around a couple times. So in which quadrant would the terminal ray of an angle fall that's 860? So you're going to start, you're moving in the positive direction. Well, I just went 360. If I keep going, I just went 360 more. That was 720. And then you're going to keep going. How many more degrees do you have to go? Well, if I did 860 minus, I already did 720, that's going to give me 140 degrees more. There I am, quadrant 2. All right. Exercise 3. Coterminals drawn in standard position will always have a measure that differ by what multiple of? And remember, when you're going around and round, you are always going around a total position of 360 degrees. All right. Continuing, now this kind of falls in the same line, but just different ways of measuring. So in everything that we did here, we were always measuring it in degrees. There's another way of measuring, and that's in radians, and you're going to ask, well, why do we have that? And that's going to come a little bit later, so just kind of stick with it now, okay? So when we're measuring in radians now, to convert degrees to radians or radians into degrees, there is your reference, there is a reference table, or you're just going to multiply your degrees by pi over 180. Or the other way around, it goes 180 over pi. So 180 degrees, that's considered pi. Okay, so in a radian measure, 180 degrees is pi. 360 is 2 pi, which makes sense because if I'm calling a half of a circle pi, then I would complete it again, 1, 2, and we call it 2 pi. Then, well, what would 90 degrees be? If this whole thing is pi, this is half. So 1/2 pi, or what we'll call it pi over 2. Okay. 1 degree. Well, think about our formula. 1 degree, you multiply that by pi over 180. So 1 times pi over 180 is just pi over 180. And then 270 pi, okay? Again, if I did degrees into radians, okay? And then if you want to use your calculator, you can do 270 divided by 180, math, enter, enter, and that's going to give you 3 over 2. So then the answer is going to be 3 pi over 2. So a little bit later on when we start graphing some of these different functions that we're going to be getting into, this is going to really kind of rear its ugly head and make a little bit more sense. So here's some practice, okay? If you want to hit pause, practice doing that, go for it, all right? So state all of your answers in terms of pi n to the nearest 10th. So they kind of want you to write it in one way and then throw it into your calculator. So in all of these, we're converting degrees to radians. So we're multiplying everybody by pi over 180. We're using our calculator. So first I would call it 1/4 pi or pi over 4. If I'm throwing that into my calculator, it's going to become 0.79. Here, multiply that by pi over 180. That's going to become negative 2 pi over 3. Now, there are some people that say, oh, it should always be positive, and some people say, oh, it really doesn't matter. If you want to make it positive, remember, we can always do negative 120 plus 360. That's going to give you 240 times pi over 180. And so the positive answer to that would be 4 pi over 3. So technically these are the same things, just measuring in different directions. Okay, and this would be approximately negative 2.09. And I didn't write this other guy down. Okay, so if I want to grab a calculator, for those of you that would be really upset if I didn't give you the answer, 4 pi divided by 3, 4.19. And again, it's the same thing, just one's measured in one direction and the other is measured in the other direction. Okay, final one. And that's going to give you pi over 6, or if you put that in your calculator, it would have said 1 over 6, and that's going to be 0.52. All right. So now let's go the other way. Let's convert each angle to degree. So now they're giving this in radians. So I always know an angle is in radians because there's going to be a pi in it. Okay? You always know an angle is a radian because there's a pi in it. So if I'm going to convert this to degrees, we don't want pi anymore. So you do upside down, 180 over pi, because that ends up canceling out the pi. And then, or you do 180 over 6, and that's 30 degrees. 180 over pi, that ends up canceling. You put 7 divided by 4 times 180, that's 315 degrees. And 180 over pi cancels out the pi. 3 over 2 times 180 is 270 degrees. All right, so here's a word problem for you. So the terminal side of an angle is measuring negative 7 pi over 6 in radians. Now, in which quadrant is that in? So we're measuring quadrants in degrees, but I don't have degrees. So what do? I convert. Divide that by, or multiply that by 180 over pi. Throw this guy in your calculator here. I'm going to get negative 210. Make your life easy. Sketch negative 210. So that's negative 90, negative 180, negative 210 would lie right over here, and I'm in the third quadrant. All right, so final one here. If I wanted to measure the outside of the circle, okay, the outside, not the inside, remember it's called circumference. The formula for circumference is pi times the diameter, or 2 pi r, okay, same thing. But what happens if I wanted to just measure a slice, or just this section here, right? And there is a formula that you can use if you have this central angle or the angle measure there. But what happens if you don't have that angle measure because they did it a little bit differently, okay? So if you're looking at this, here is that circumference we were talking about earlier, but we're going to call that here the arc length. Okay, this theta, okay, that's your angle measure. Now, in this case, okay, that angle measure can be in radians or degrees, but we're giving you S equals theta r. So this is when they're giving it to you in radians form. Okay, so you don't need the degree measure. And then r, that stands for your radius. Okay, because again, that arrow is going around, makes a circle, so that's why your radius. So number 7, in a pendulum swings through an angle of 0.55 radians. Okay, So a pendulum, okay, there it is, and it swings, and it goes back and forth, okay. Dotted means you can't see it, right? So there it goes. So the angle measure that just created was 0.55 radians. And they want to know what is the distance that its tip travels if it has a length of 8 feet, right? So that tells me that the radius is 8 feet, and it wants to know, well, what is this distance here? So they're asking me for the arc length, okay? S equals r theta. X equals 8 times 0.55, and that is going to be approximately 4.4 feet. All right, so there is your work with angle measure. Stay tuned. We're going to keep rolling through all of this trig stuff in the next few days. If you're not familiar with what we're doing here, if you go to www.cimath.com, I have all of these worksheets that we're working on that you can get and print out. If you liked it, give a thumbs up, subscribe, and turn on those post notifications so you know when the next video is coming out. All right, have a great day.